Welcome to this introduction to the Power Stamp Alliance and the Alliance's core intent, technology, and specifications. The following information will explain the premise and basis of the Alliance with an outline of the products and how they are to be used in the intended application of providing power to the most demanding of applications. The primary purpose and motivation of the Alliance is to provide a multiple-sourced standard power supply solutions to applications where the demand is for power conversion from a nominal 48-volt input to an output of low voltage at high current. As the power demands of processor and memory devices increases, the PSA specification provides a scalable solution that can be used in tandem with existing power conversion devices. The product definition will be at the level of both footprint and function only in order to create a standardized solution that will use STICs as a basis for the control of the stamps. This is intended to allow practical multiple sourcing and qualification. Currently, the membership of the Power Stamp Alliance consists of 4 leaders of the power industry: Advanced Energy, Bell Power Solutions, Flex, and ST Microelectronics. Load Slammer's participation as an associate member brings expertise and harmonized test processes to the Alliance. There are multiple benefits of the standardized solution that the PSA defines. They are: the units from all vendors will be of the same size and footprint. All will fit and function on the defined dimensions. The PSA solution is focused on the high current, low voltage power supply that is required by, but not exclusively, ASIC and FPGA devices, AI accelerators, GPUs, CPUs, and memory. The resulting solutions are all to be built from existing processes and components, allowing for high-volume production with minimal risk. The solution is extremely flexible and can be used for power rails rated at up to 1,000 amps by adding stamps. However, if there are stamps that are required to take account of peak loads but are not expected to be required to support the average current demand, the number of operational stamps can be scaled by the demand automatically, which has the benefit of retaining the maximum efficiency of conversion. The solution has a power stage that has inherent input-to-output isolation. The solution's mechanical attributes have been defined by the application of supplying power to a processor device. 4 PSA stamps can be placed alongside one edge of a 58 by 58 mm processor device. In the example shown, this means that up to 400 amps can be generated in space next to the processor. The solution is fully digitally controlled, allowing for AVS or SVID control of the module with all attributes supported. Internal to the units, this also enables the performance of the solution to be optimized for the application. The solution will be proven to be compatible with different processors. Reference design boards will be made available if needed. The example shows a typical application that uses 2 VR13HC processors and associated memory devices. Here, up to 400 amps will be required for the processor, and 200 amps will be needed for each of the banks of memory. The concept of the solution is to use a main power stamp and incrementally increase the current rating of the power conversion stage by adding satellite stamps. All power stages, main or satellite, are inherently isolated. The main stamp is a standalone power converter rated up to 100 amps. It carries the function of all user and processor control interfaces to the power conversion stage. The main stamp also provides all control functions for up to 11 satellite stamps. The satellite stamps receive the control function from the main stamp and provide the incremental power of 100 amps per satellite to the power conversion stage. There is no user interface to the satellite. This is not required. The combination of main and satellite stamps is defined by the target application, but the number of satellites that are operational at any one moment can depend on the application load conditions. If all satellite stamps are not required to supply power, they will be disabled, leaving the remaining stamps to operate as efficiently as possible. Such a combination of main and satellite stamps should be considered as a single, multiphasic power converter. This combination means that the cost of the combination of main and satellite stamps can be minimized, as the satellites carry fewer control functions and component. The physical size of the units is defined by the target application of providing a power solution to server processors. The PSA defines the envelope dimensions only so that the implementation of a design solution can be developed by each of the members of the PSA. The 12.7 mm width means up to 4 units will fit alongside a processor, including some clearance space between them. The length of the module has also been chosen to fit the demands of the area available in the host PCB, so that the units do not overlap any data line routing. Finally, the height shown is a maximum dimension of the PSA envelope. As shown here, the main unit will consist of a carrier PCB that contains all control functions with a satellite power stage mounted on top of it. The main unit will be terminated on the bottom surface of the controller PCB by LGA pads. All power connections on primary and secondary sides are moved to the very extremes of the module to allow optimum design of the application. The placement of the terminations has been carefully considered so that signals of similar type and function are grouped together and moved to the outside edges of the module to allow for the easiest possible connection to the units and between the main and the satellite stamps. The groups of pads through the middle of the unit are reserved for connection to primary and secondary ground connections. The pin numbering and naming follows industry standard conventions. The terminations to the controller stamp module are of a LGA termination type. As can be seen, the number of terminations required to be made to the satellite stamp is far fewer than on the main stamp unit. Only input and output power plus the control functions received from the main stamp are needed by the satellite stamp. The combination of controller stamp and up to 12 satellite stamps results in an entirely scalable solution that is entirely independent of low-voltage auxiliary rails, and all that is required is a 48-volt supply voltage. The terminations to the satellite module are of a block pin type. As can be seen, the number of terminations required to be made to the satellite stamp is far fewer than on the main stamp's unit. Only input and output power plus the control functions received from the main stamp are needed by the satellite stamp. The satellite stamp can fit onto the main stamp's footprint if required to do so. The satellite stamp's pin numbering, naming, placement, and dimensions are all identical to that used for the main stamp. The combination of main stamp and up to 11 satellite stamps results in an entirely scalable solution, both in design and in operation, that addresses the challenge of providing hundreds of amps of current at low voltages with a standardized, multiple-sourced solution. The PCB layout for the power stamps is extremely easy and was a driving factor behind the pinout of the power stamps. The units have mirrored power connections from side to side, which means interconnect between them is very simple to realize in hardware. For example, the 0-volt connections are right next to each other when the units are placed next to each other. 40% PCB real estate saving can be realized by employing a direct conversion DC-DC approach. As can be seen in the slide by the direct comparison of PCB size by scaling based on the CPU socket. The first power conversion stage, 48 to 12, and the external components required around that conversion stage are not required, and therefore all of that considerable space can be saved in the application. Up to 1200 amps output is possible by implementing 2 stamps per phase. Clearly symmetric layout between the stamps is very important, but with growing demand for current at low voltage, this methodology gives an avenue to higher current. The Power Stamp Alliance has now generated many common resources, including all of the reference resources to support a successful layout, specifically the PCB Allegro files for the modules. A common graphic user interface has been developed, which all PSA-compliant hardware will operate with. White papers for application-specific items, such as higher current generation and cold plate cooling, are now available on the powerstamp.org website. For more information, please visit www.powerstamp.org.